Today we're going to talk about forces, balanced and unbalanced. Last class we talked about the essential question, and it says, how do forces affect motion? So we did a quick balloon activity, and what we did is we blew up a balloon, and we talked about the forces that were acting on the balloon as we were blowing it up. And when it was being inflated, the force of me forcing the air out of my lungs into the balloon was stronger than the balloon itself. So that was an unbalanced force. It was moving, it was expanding. After the balloon was inflated, and I pinched it off, it wasn't inflating anymore, and it wasn't deflating. That would be a balanced force. So we talked about that. Then we also did a little demonstration with the arrows and using vectors, and we drew a box, and I think I used the bookshelf, and we showed the direction of force. So if you can use arrows, and we used the box and said it was a force of 10 newtons acting or pulling on the object to the right. And then if the object is not moving, the object won't move to the right anymore. It just kind of stays by itself. And finally, we drew another arrow going back the other way. Okay? And I think the arrow going to the left was 15 newtons, while the arrow going to the right was 10 newtons. So the net force would be 5 newtons. And so that was a quick little introduction to forces. Last class, we did a few activities. So let's get started on the actual notes. So what is a force, and how does it act on an object? And the first thing you need to know is that a force is a push or a pull. Okay? So all forces are vectors, which means they have both size and direction. Okay? The size is how many newtons. The directions is if they're going up, down, left, right, and basically the direction they're going. Okay? The unit we use to express force is called a newton. Okay? And finally, forces do not always cause motion. Sometimes we talk about the balance force. So like a tug of war, if two people with equal strength are pulling on a rope, there might not be any motion there because their force is both the same. So here's another one. So what is a force, and how does it act on an object? Okay. So forces act on objects that are in contact with each other, such as a force is called a contact force. So the bicycle here, when it's touching the ground, that's a contact force. Friction is an example of a contact force. So we did our lab last class with the box and the weight, and the friction of the box on the countertop would be a contact force. So car tires, they rely on friction to keep things moving instead of sliding off the road. Think about the icy roads when it's snowing outside. If you have too much snow on the road, your contact force is less and your friction is less, so you might start sliding. So what is a force, and how does it act on the object again? The forces can also act on objects that are at a distance. Think of gravity. Okay? The sun's gravity keeps the Earth in motion around the sun. The space shuttle trying to go up into space, gravity is acting on that as well. Okay? You can think of magnetic forces. Okay? So a magnet can have an effect on a piece of metal or a paper clip, and doesn't have to be touching it. It could actually be several inches or centimeters away. So we just talked about gravity and magnetic forces that can act from a distance. So what happens to multiple forces when they act on an object? So here's a good example down here in this picture. We have a group of people doing a tug of war. One's pulling 300 newtons to the right. The other group's pulling 320 newtons to the left. Who has more force? Well, it's the group that's pulling to the left. And they have 20 newtons to the left more. So it's a net force of 20 newtons. So the net force is a combination of all the forces acting on an object. When a force acts in the same direction, they're going to be added. And if the force is acting in opposite directions, you're going to subtract them from the larger force. Okay, so a net force of 0 means forces are balanced and will not cause any change in motion. So everything will stay the same. A good example is if someone's pushing the car here, in this little toy car, another person's pushing the toy car, and it's staying still, that means both individuals are pushing the car with the same amount of force. So there's no motion. The truck down here. So balance force, again, 100 newtons to the right, here's another 100 newtons to the left, the truck won't move because the net force is 0. However, unbalanced forces will produce a change in object's motion. So, using this truck down here at the bottom again, 100 newtons here, going to the right, and only 60 newtons pushing to the left, that means the truck will move to the right because there's more newtons pushing to the right, okay, more force. Okay. Acceleration is always the direction of the net force. So what happens when multiple forces act on an object? Again, we have this individual here. He's trying to push a box, just like my shelf in the classroom. Okay. And let's think what some of the forces are acting on this box. The first one is gravity. Gravity is pulling down. Okay. So you have that frictional force. And then you have the individual who's trying to push the box to the right. There's a force of someone pushing the box to the right. There's a couple different forces here. Gravity and the guy pushing the box. Okay. Alright. This was our lab we were going to do. This is what is the effect of a balanced and unbalanced forces. Okay, a force is a push or a pull, we talked about, and forces are measured in newtons. Forces can cause objects to move, stop moving, change speed, or change directions. So in the lab that we did, you investigated the effects of balanced and unbalanced forces on the object. You also considered how the net force determines the object's direction of motion. Remember that the net force of an object is the combination of all the forces acting on that object. Okay, so you guys already did this lab in class. We did it with the blocks and the 2 different spring scales, and I think you were in groups of 3, and you had to see which side was stronger using the spring scale. If it moved, it was unbalanced. If it did not move, it was a balanced force.